Okay, this is the summary of the addition and the multiplication rules for the probability. Addition rule for the probability of A or B, or is the key word. The word or suggests addition. And when adding the probability of A and the probability of B, we must add in such a way that every outcome is counted only once. The multiplication rule for the probability of A and B. So the word and for two trials suggests multiplication. And when multiplying the probability of A and probability of B, we must be sure that the probability of event B takes into account the previous occurrence of A. So main thing I want you to kind of key in on right now is the word or we add, the word and we multiply. So A doesn't go with A. A goes with or, and M goes with and. So multiplication and, addition and or. Okay, this problem that we're going to do right here, it says use the data in the following table which lists the drive-through order accuracy of popular fast food chains. Assume that the orders are randomly selected. If one order is selected and so forth. I'm going to take this chart and total it up just like I've been doing, but I'm going to stop the video, total it up, and then I'll come back so the video won't be quite so long. Okay, well, let's see what's going on. We want the probability of getting an order from restaurant A, or what does the word or imply? Or implies addition, or an order that is accurate. So what we are looking for is the probability of restaurant A or the probability of accurate. Okay, so we have to add. Right, when you add, you have to subtract the overlap. So we're going to talk about all of that. So what we're really going to do is find the probability of A plus the probability of it being accurate, and then we're going to subtract the overlap. Well, what is the probability of A? How would I go about doing that? I'd say equals sum. The probability of A is here divided by the total. Okay, that's the probability of A. The probability that the order is accurate is going to be what? We want to do equals sum. The probability that it is accurate, that is that top row. That's that number divided by the total. So we've got the probability of A, we've got the probability that it's accurate. We need to figure out what the overlap is. Okay, so A is right here. So this part right there shows restaurant A. Okay, I'm going to highlight that. Okay, for it to be accurate, that is that second let's just highlight it in a different color. Okay, so you can see the overlap. Where does the yellow and the green intersect? What number is it? The 331. So the overlap would be equal to the sum of the 331 divided by the total. Okay, so now we've got the individual amounts. Now let's put it together to get our final answer. Okay, we're going to equal the sum of what? This number plus this number minus the overlap, that number. And what do we end up with? That's the answer we want to plug in and see if we have it correct. So that would be 0.905. If it's 3 decimal places, be aware. Okay. Then it says, are these events of selecting an order from restaurant A and selecting an accurate order disjoint? These events are not disjoint because you see the overlap right there. Because it is possible to receive an accurate order from restaurant A. Okay.